The correlator consumes about 150 kilowatts of power, and not just ordinary power. The power from the mains is unsteady, it fluctuates, and it can turn off. To protect the correlator and to run the correlator, we have a very interesting power system, and Brent is going to explain to us how this works.
So coming from the power grid, 480 volts, three-phase power comes in here. This box is actually a big transient suppressor box, devices inside there. Comes up 480 volts, three-phase, comes into this unit, and each of these is 200 amp power control units going from 480 volts to 54 volts DC. And there's enough to supply the full 170 kilowatt capacity of the system. And then the output of those essentially is connected to the battery banks. And then there's breakers coming off these that go through all of these cables to all the racks in the system.
So if I understand right, the power comes in as AC, it goes to these rectifiers, it turns into DC.
That's right.
Which feeds these batteries. Let's go take a look at them along the side here. So all that rectified power goes into these rows and rows of batteries, like car batteries on steroids.
Yeah, they're kind of like car batteries. They're actually for telecom or telecommunications central office systems. So this is the kind of system you would see in a central office where your telephone switching system is. And that 48 volts is chosen because it's high enough voltage to keep the current requirements down, and it's low enough voltage so it doesn't have any shock hazard.
And so the purpose of this is both to protect the correlator against outside influences, as it were, because it's a $20 million instrument and we don't want to have it burned out. And also to protect it against a complete power and unexpected shutdown. How long can this correlator run on these batteries?
So it's set to run for 5 minutes on batteries, and in that time it'll allow for the graceful shutdown of the system.